Welcome back. Today we're going to be studying 2.5, Proof with Constructions. We're going to be looking at what is called auxiliary lines, or lines that I add using my ruler to be able to prove my point. You're going to need your booklet, definitely your ruler, an erasable pen or pencil, and a compass may be helpful. Got them? Great. Opening up our booklet to 2.5, Proof with Constructions. We're going to start with something that looks intuitive, but we don't know why it's true. We're being told that AB is parallel to DE. And let's get some more color here. And BC, notice a matching arrow saying these are traveling in the same direction, is parallel to EF. And we want to prove these two angles are the same. Now they look the same. I could even measure them to be the same, but I won't know they're the same until I come up with a strict logical argument. But the problem is there doesn't seem to be anything relating these two. And that, my friends, is where what's known as auxiliary line comes in. One of the things I always do whenever I'm working with parallel lines is that if they only show me a little piece of the parallel line, that means I'm missing quite a bit of the picture. So I'm going to use my handy dandy ruler, and I'm going to extend out my parallel lines and see what intuitions I can get about the relationship between these two lines. Notice some people find it really helpful to use colors to be able to do this. Some people, on the other hand, like to keep it all monochrome. You can do what works best for you. So I'm looking at this, and it seems to me that there's something we could do with this. Like, for example, I know that this would also be B degrees. And if I look at this line as a transversal of these two parallel lines, this would also be B degrees. And then if I change my perspective, and always feel comfortable rotating the book or looking from different perspectives, this angle and this angle are corresponding as well. So I can make the argument that B is vertical to this. If I look at it this way, this angle and this angle are alternate interior. If I look at it this way, this angle and this angle are corresponding. And I'm done. I could even say, well, from this angle, if I turn it this way, that this angle and this angle are corresponding as well. So I have a couple different ways to argue this out. None of these are wrong. They're just different stylistic arguments, the same way that you and I would use slightly different vocabulary words if we want to emphasize different ways. So I'm going to start laying out my argument using primarily corresponding angles. So I'm going to say, first of all, I'm going to extend the parallel lines. That's my first statement. And I know they have to intersect somewhere. Parallel lines to intersection. Because if they're not parallel, then they must intersect. There are only two types of lines in the Euclidean world, parallel lines and intersecting lines. Okay. Next layer of my argument. This angle, should I label this angle something? Shall we call this angle, instead of it just calling it B, let's call it X. B must be equal to X because if, well, this line and this line, CB or BC, doesn't really matter the order, is parallel to EF, then corresponding CRR angles are, and here's our congruent sign, we're going to say equal with a little curved tilde on top. So they're kind of equal. And in turn, we can also say that E is equal to X. Because if, remember, turn it the right way. Sorry about that. We're talking about how if you turn it this way, you can really see that angle X and angle E are corresponding angles compared to the parallel lines ED and BA. So if AB or BA, doesn't really matter the order, is parallel to ED, then corresponding angles are congruent. Remember, it's that funny little curvy line over an equal sign because they're not the same because they're not in the same location, but they do have equal measure. So E measure is equal to X. So however many degrees angle E has, it's the same number of degrees as angle X. And therefore, if B is equal to X and E is equal to X, well then B and E must be equal to each other. And we can say that by substitution. The key idea in this type of proof is that you can go ahead and you can create the relationships you need by adding lines. Like for example, in the practice you're going to do today, I'm going to suggest a couple lines to add. Notice here again you have the different parallel lines. You know that these guys are congruent, are parallel to this one. You know that these guys are parallel to this one. You're trying to prove that A, B, C, I always mark my angles, is congruent to CDE. Based on what we did here, you may already have the necessary angle. But if we look at a problem like 2, where we know AB is parallel to CD, and BC is parallel to DE, so you can kind of see the two sets of pairs being set up. And we're trying to prove that these two are parallel to each other. It may be helpful to extend out the parallel lines and see if we can think about a relationship where two angles always add to 180 that involve parallel lines. Which set of pair of parallel lines always equals 180? And lastly, in this proof, it should be number 3. I apologize, I didn't catch that. You might want to think about what can you add to prove that D is equal to A plus B plus C. You might find something, let's see, you might find adding a line across might be helpful. I'm so excited to explore all these different options with you in class, and I want to wish you a wonderful rest of your day.